Yes.
Okay, welcome back to the lecture. We are going to have a brief look and introduction to the robots and robotics. The slides I'm using are coming from Professor Bajd and Miley. I don't know them. Sorry about the pronunciation, but I got permission from them to share them with you, and I hope they will be useful for this class. In some cases, I have added some other notes to the slides, so these are not exactly what I have received. I have made minor changes into a slide as well. So, talking about robot is a kind of combination of science, engineering, and also sci-fi, and also myth about robots. Concept of robot is kind of related to the creation, because when we talk about robot, first thing pops in mind, specifically for people who are not industrial or people who are uh, not technical people, they think about humanoid robots which look like human, behave like human, they have behavior similar to what we do. And I don't know if you know an author, Isaac Asimov. Have you have heard of him? Well, long back, teenage stories. Basic rules of robots. And you have seen these in movies and different uh, fancy publications, uh, written or movies about robots. But when we talk about robots here in this class, we're generally talking about actually mechanical creatures which can make moves. So the concept of creating a machine that can operate autonomously dates back to the classical times. But research into the functionality and potential uses of robots did not grow substantially until the 20th century. Actually, when our engineering became mature enough to build devices which can, uh, move and can work uh, using mechanical or electrical forces, it can be controlled as well. So control is a key turning point in designing robots. Throughout history, it has been frequently assumed by various scholars and inventors, engineers, technicians, that robots will one day be able to mimic human behavior and manage tasks in human-like fashion. Today, robots is a rapidly growing field of research and technology. As the technological advances continues, researching, designing, and building new robots serve various practical purposes, whether domestically or commercially or military. You see robots all over the place now. It's not just industry. You see robots in, even at home. You have these kind of mowers that can move, and or vacuum cleaners that can move around in the house and do basic things. There are concepts of robots. Even we can add to this definition. We have also some software robots. Okay, the concept of autonomous uh, operation has moved to software as well. You have bots on internet. They continuously work, collect information, send messages, monitor, those things automatically. The difference between robotic we're talking about and those kind of bots is all robots have a physical or mechanical implementation. They have a physical or mechanical structure. So in that aspect, robotic can be considered as an interdisciplinary branch of engineering and science, that includes mechanical, electronic, computer engineer with different shares, depending on what kind of robot you have. The mechanical part might be bigger part, or computer and electronic part in other kind of applications can be the more important part of the robot. The field overlaps with electronics, computer science, artificial intelligence, mechatronics, nanotechnology, and even bioengineering. And I have to make an interruption here. I also have uploaded these slides online. If you want to download them and follow the slides, they're available now. Robotics deals with design, construction, operation, and use of the robot. So I would say probably it goes backwards. So using a robot, larger people, a larger number of people know how to use robots, and the operation actually. But the construction is higher level of information, and design is higher level of information as well. We try to move, over three together. Probably more on design and construction part because it's more theoretical part, as well as computer system and control, sensory feedback, and information processing. From my perspective, robots are very similar to computers. In computers, you can program, you can interface with the computer. Your computer can interface with other computers, with the environment. And, you might program which works properly. You might write a program which fails. You might write a program which works generally, but sometimes fails. And, exactly same thing with robots. The big difference is in robots, you have physical movement. That's a big, big difference. So what I'm doing in a computer might not make any sense in physical world. I ask my computer to do something, and it just runs the program and doesn't work or work. But in a robot, you write a program. This program must be compatible with what you physically have as a robot, what you physically have as your environment and workspace. So it's similar, but more restricted. And I think it can be more difficult because you have to have knowledge of what you have in your robot environment and the capabilities of your robot. There are similarities, but also big, big differences. So, definition, robots can be used in many situations for lots of purposes. But today, mostly we are talking about manufacturing robots, which are used in manufacturing process for production rate, for more efficiency, and for jobs which are dangerous or even impossible for human to do, for environments which is toxic or very difficult or hard for human workers to go and work. Many robots are built to do these jobs, and there are environments which are hazardous, which there are hazards for human to go. Like example is defusing a bomb or finding survivors in an unstable, collapsed building or structure, and exploring areas which never human can go. Robots have been sent to Mars before even human can go, right? So if you want to give the credit, you have to give the credit to robots. Actually, robots have been working, and robots are already there before a human being can think of moving to Mars. All right, and by definition, robot is a pre-programmable manipulator to perform specific mechanical functions such as move, mature, and part. So this is a very basic, very simple structure of the robot, specifically focusing on industrial robotics. And robotics is a science dealing with design, construction, and operation of robots. So we are talking about design, construction, and operations mostly in this class. Okay, any question? What do you think about
No.
robots? Yeah, okay. So, what do you think? Can robots one day do whatever human can do? So, can robots robots do whatever human do? Future, actually, in the future. What do you think? You say yes? Everything?
Yes,
Do you mean mechanically or mentally?
everything. I think it's limited by the human setting it up.
Okay, so for instance, you think it's possible for a robot to do figure ice dancing, for instance?
Yes,
Oh, that will be a tough call, right? Or doing gymnastic, think about the mechanical aspect of. Oh, I have to see the messages. I can't see them. Sorry. Yeah, you believe that it's possible. Okay, already doing it. Really? Well, I know robots were to write the book. Yes, yeah. Well, I've seen that. It's actually on Amazon. You can search for the first published book by that. You can buy it. I think I bought it accidentally. I didn't want to, just I did. Well, it's, but if I want to talk about robots and what they can do, these robots can do. Uh, you can divide it in two parts. One is intellectual, the other one is mechanical. Okay, human body mechanics and movement is, well, it looks simple. Human looks very vulnerable. All those limitations we have. But give it or not, the mechanic and the way our body works is well, it's very, very difficult to repeat by mechanical devices. I don't know if you follow this company called, I think it's Boston Robotics, owned by Google for a while. Google sold it to a Chinese company, investment company called SoftBanks. They are really doing good things, a very, very beautiful movement, but they're still not complete. Think about just simply your hands, fingers. The accuracy you can work with the movement and everything you have, or you know, in our body. Do you know how many skeletal muscles we have? Muscles which are connected to our skeleton, which can by which we can make movement. Do you know how many we have? I guess
isn't it
well,
close to 300?
300, around 300, 600. Burhan said too many. So any other suggestion? How many skeletal muscles we have? 10,000. Oh, no, that is too much. But well, talking about muscles per joint. Well, this is a general term, skeletal muscles which are connected to our skeleton and by which we can make movements. All right. So normally, you know, It's not the case for everyone for sure, but on average, we have 300 muscles each side, moving muscles, okay, moving skeletal muscles. Makes 600. 100 is right. 600 muscles means 600 actuators, actually. Now, think about a robot, 600 actuators. Well, people who are working with robots, how many actuators normally we have in a robot, in an articulated robot? But not number of freedom, not number of freedom. How many actuators? Around, right? For each movement, we need an actuator. But it's around 6, 7, 10. Maximum you can think of very, very, if you want to make it very complicated. It doesn't reach to 20 for sure. Okay? So you have a robot with 6, 7, 10 actuators you can control. You want to compete with a robot with 600 actuators. It's not an easy task, okay? I'm not saying it's impossible, but to reach to that level, we have a long way to go. We have to find out how to make control all these in harmonized, manner. And, well, when you write something, think about that. How many muscles you use to grab a pen, to move a pen, to write something beautifully, or do painting, or at the same time doing other things together. So it is not easy to do, but hopefully we will be in future to have robots physically move like a human. So that's why I'm not worried about our jobs. Robots cannot take our place in close future, and hopefully never, hopefully never can get steal our jobs. Okay, and intellectually as well, we have a long way to go. Uh, Thinking about image processing, voice processing, memory, judgment, decisions, calculations, and computing. All these computers, robots are far, far from us. At least I don't think there is a threat for my lifetime from computers or from robots. Okay, any question or any other thoughts you want to share? Okay, so no one worries about robots. Normally, how many actuators are there in a robot? Well, I agree with what Nikita says. Well, we in many robots we have 6 degree of freedom in articulated robots. 6 freedom of DOF of 6 degree of freedom means you normally at each joint you should have an actuator. So we have 6, it should be around 6, not less than 6 definitely. It's normally 6 uh, or more, but it's not too many. You can say for each joint I have 2 or I have more, but it will be between 6 and I think 10. Shouldn't go higher. I don't know. It's the best of my knowledge. I don't know. If anyone else can say, who else said working was, let me check. I know Gino and Mike, they said they have been working with robots. Jordan. Lou, are you working with robots? No. Okay. So you're off the hook. Okay. Romeo, it was you, right? Yes, Romeo. Okay. You answered the question. How many actuators we normally have? Yeah, 6 plus some actuators for groups. Yeah, Jordan, yes. That's right. So it's 6 plus. 6 plus, okay? If you have n number of freedoms, okay? If you have degree of freedom, your actuators should be n plus. N plus for few more actuators, probably auxiliary actuators like tweeter, or for some you might have more than one motor, or combination of these together probably. But it's close to the degree of freedom. Did you get your answer, Nasir? Okay, good. Thank you. Let's get back. All right. So classification of robots. This is a general classification. I like it because it's more. It doesn't limit us to just one specific type of robot. Divided to 4 categories: robots. What happened? Robot manipulators, one class. Vehicles, which I agree with, or we have robots which can move things and use for transportation. Man-robot systems. Okay, so robots with interface interaction, direct interaction with human. Okay, and biologically inspired robots, robots which are inspired from biology. So manipulators can be divided in subclasses. A simple division. This is not the best, but very general and simple division are serial robots, parallel robots, and micro and nano robots. These are more advanced technology kind of robots. But serial and parallel, in serial robots, well, in the robot, this is a schematic of a robot. Have a look at this. You see here at the end, this is your end effector. This is where you attach your tools. This is where you have different kind of tools to work for you. We call it end effector. This is the end of your robot. Okay. In the schematic, you see the end effector here, and this is the base. All right. The connection between base and end effector go through one path. I have only one path from base to the end effector. We call those serial robots. Robots which are, parts are in series. One is connected to the other one to the other one, and to the end effector. We call these serial robots. Examples are, most, not all of them, but most of robots you see in industry are serial robots, articulate robots. Here is the base connected to one joint, another joint here. Change the color. One joint here, and one joint here, one joint here, one joint here, and you see these are in series with each other. So similar to what you have here. This one can rotate this way, this one can rotate this direction, in this direction, and here is your end effector or end of your robot, and you see the connection is in series between them. Okay. Unlike parallel robot, you see in parallel robot, you might have more than one connection. You see this robot, in this robot, this can be used for a table. Okay, you want to have a table which is regardless to what happens here to the base, always stays in one pose, always is flat. Okay, so by changing these connections, can be pneumatic or hydraulic or whatever the translational, We keep it. So you see, you're between your base and your end effector, there are several pathways. There are several pathways. Okay. I have a question. No question. Sorry. We call this parallel robots. We call these parallel robots because we have more than one path. So robot based on platform are connected with legs, incorporating passive joint and translational actuators. So here you see in this on right hand side, where is the robot in this figure?
Underneath.
Can you see the robot? Robot. Yes, exactly. The platform under the feet here. This is the, oops, sorry. This is the robot, okay? Not the human. No robot. Robot is here, down here. So in this, this is a robot connected from, this is bottom up. We also have robots in industry like this. What you see here, this is another robot connected. So it's connected to the roof and mostly used for pickup, applications, for pickup applications from, so let me show you one example. They do have example of this type of robots. No, not here. But you can search for robots and in, I don't know, can I share with you here? The good thing about class was it was much easier to, no, this one. Um, nope. Okay. But you can search. You can search for it. Very similar to this ABB robot you see here. Here, this is the base of the robot connected to the here, connected to the robot. And these are arms of the robot. They easily can pick up things and displacement. Later, I'll talk about the dynamic and also kinematic of these kind of robots are different, slightly different with serial robots. Basically, what I can tell you with parallel robot, you are reducing your freedom because there are more bonds connecting the end of the robot to the base. Okay, so generally, uh, it's more limited in terms of kinematic, but they're mostly considered to be faster, more accurate, and they are very, very popular in pick and place robots. So you have a production line, and these type of robots are connected to the roof, and they just pick things and place them well in a position. It can be a box or it can be in manufacturing on a conveyor. Okay, a parallel robot. Have you ever any parallel robot in your work, guys who are working with robots? No.
Yes,
I have one in my lab.
Uh-huh.
we use one for putting apples in trays.
Oh, all right. Okay. So let me see. I don't know. When I'm playing video on YouTube, you can hear the voice or not.
We still hear you when you watch a YouTube
Oh,
video.
you hear me, but you don't hear anything on Google, right? On any background. So let me turn
That
it.
one doesn't have really any sound.
I see. So let me share this. No. Um, okay. Let me see if I can do it. Selecting variable. All right, good. So let's try to share something. Yeah. So do you see? Can you see this YouTube thing?
Yes,
Yeah, yes.
Can you hear anything from it?
no.
Wait, so why it's not sharing autoplay? Where is?
Now we can, it sounds like.
Oh, you can? You can hear?
Nope, that was my accidental another video.
Oh, sorry. So let me, if there is a setting here, all right. So hold on. Okay. Uh, backgrounds is nothing, but later I have videos which are talks in. So this is parallel robot. It can work in even millimeter scale. Okay, that's a simple example. No, background music was so loud. Okay, going back to our presentation. Okay, so these are called um, parallel robot. Later, in terms of kinematic and comparing this robot with serial robot, I'll have a brief discussion about parallel robots. And there are benefits and downsides of parallel robots, and those will be discussed. Do you know any issue with this parallel robot, Jordan? Have you ever seen that problem, or people who are working? Do you know what's wrong or what can be wrong with these robots, parallel robots?
Um, Sorry, with the particular robot that you have in the picture here?
Generally speaking, there is something, well, there are some issues with this robot, which might happen, not in every robot.
I know we always have issues with that robot because it can be bound up on itself pretty quick and you have to open up the top and readjust it,
Oh,
like the linkages and stuff.
exactly. And with these robots, the problem is they have, I'm not, well, not the capability, actually, the vulnerability of become collapsed, okay? It can be shown by calculation that when you have these type of robots, there is a possibility this robot will position, reteaching, yeah, can go to a position which it locks itself and it doesn't come out without turning off. So there is a, well, in most, exactly, sorry?
Are you referring to singularity?
There is a single, not just singularity, here it collapses. It's a kind of single, well, in serial robots, we also have singularity. But in this one, because look at this, I have videos of that as well. The robot goes to the situation, and because of the, just arm length and the position, the position of the end effector, it collapses itself. It goes inside and doesn't come out, locks in that situation. You have to turn it off and just open everything back again. In industrial robots, designers have limits to it and have checkpoints to not let the robot to get locked up like this. This ABB one, you don't see that problem. But within calculation, we show that in some cases there are possibility that this robot collapse itself and well needs external help to be open. Okay. Yep. And micro and nano robots, as the name implies, these are very, very small kind of robots used for operations or for situations in which you normally don't send big robots or you don't have access to. Well, these are nano manipulator enabling pushing, pulling, picking and place manipulation, orienting, and blending and growing, in a very small or very, very, micro scale environments. You have heard of application, people talking about, doing surgeries, biomedical applications with these type of robots. You can send them inside human body and do some small changes. And well, here, because of the size and because of the structure of the robot, you have a lot more limitations. You cannot use some sort of mechanical power sources. Still, most when research scale. In industrial level, I don't know. I haven't seen industrial kind of this type of robots. I don't know if you have seen any nano micro robots in practice. Have you ever seen anything in class? No? All right. Do you want to have micro nano robots inside your body? Yes? No? All right. Okay. Well, I don't want to. Well, here actuators and sensors are completely different. They're different material. Small forces with small actuators. Sensors should be okay because sensors are themselves in micro, uh, physically in micro scale sizes. But actuating is very difficult. For actuation, they're using material. Hopefully later on we'll talk about things like piezoelectric material or small electromagnetic forces inside the robot. more in research scale, not in industry. The second category of these kind of robots are you know, transportation robots. They can be land, water, or air kind of transportation. In these robot vehicles, we have a robot which is autonomous. It can get information from environment. This information can be visual, or can be by sonar, or can be by LiDAR, different sensors, data input, and they have a computing part based on calculation of information into the robot. They can find their pathway and go. You know, autonomous cars can be considered kind of robots as this type. Okay, there are videos online for, I think it's Amazon or it's Alibaba, the supplier. You see these robots are working in an environment by emitting and displacing items, inside the warehouse. And in industry, I know in other classes we've been talking to each other regarding autonomous vehicles inside industry and manufacturing line. There are autonomous vehicles in manufacturing, and are in use already. There are different classes, different technologies used, and just basically based on, again, acquiring information, processing, and finding pathways, a combination of AI or control algorithms, sensors, and actuators. And while different interesting things in research or close to research side, there are competitions for this type of robots, and students every year gather and do soccer player robots or pathway finder robots, or different kind of similar applications made for rescue robots as well. Other examples are autonomous car, as I mentioned, and also robots we send to other planets. Just at the moment, it's focus on Mars. Who knows? Probably other planets will be targeted as well, using this type of robots in future. Drones or robots they might not be completely autonomous, but they are remotely controlled. They need to have sort of autonomous as well. But they're very popular. You hear about them. They've become kind of popular technology in military. Not just in military, they can be used in rescue, in border monitoring, in climate monitoring, in many different applications. And drones also in small size. They have applications from entertainment to industrial to military, and even to medical rescue applications as well. Underwater vehicles, they also they have very interesting applications, from oceanography studies to just even Great Lake next to us. Robots, universities are working on robots to be sent to the bottom of the river, to the lake, to study, to gather information, to monitor pollutions, difficulties, temperature, contamination in the water, and everything. So, all over the place, autonomously or autonomously connected central control location. So any specific idea or anything you want to say about autonomous or robotic vehicles? All right, good. The other category, based on what we have in this book, is man-robot system. where you have robots closely working with a human. With a human. It can be haptic robots, robots which you have, in touch, with hand touch with them. It can be tele manipulators, like telesurgery, teleoperation robots, and can be exoskeleton robots. In haptic robots enable to the operator to sense of touching the objects in the virtual environment displayed on a computer screen. Uh, still in research mostly, because transferring sense from another environment to human body uh, is not an easy task, because we don't have that much sensor or those type of sensors in the environment very well, and also we need very fine-tuned actuators uh, to be used by human hand or human body to get the same sense from environment into human. But it's there. Well, applications in gaming, entertainment industry in general, and also in some kind of very accurate movement and interaction with environment. There are, well, powerful haptic robots provide assessment and training of paralyzed upper extremity movement in stroke patients. So more in rehabilitation and medical application of this type of robots. In medical, robots are becoming more and more useful and popular in applications, specifically in cases when you need continuous accurate monitoring or help with a patient, which you cannot have a nurse or a doctor to work like 24-hour day, 24-hour, just continuously watching or working with the patient. Telemanipulator, again, for places which are difficult or hazardous for human to go, or for telesurgery, or for teleoperation. These robots, actually what you have is a robot with similar to other robots we know and we use. Also, you need a communication system to connect these together, and also you need an interface for human to work with. Well, it looks simple, like using the same robot I'm using in my manufacturing line from home. Think about that. You're sitting in your home, you're watching through your monitor, and with a handle or with keyboard, you're trying to control a robot like several kilometers away. Sorry, just give me a second. Sorry for interruption. Can you hear me back? All right. So imagine you want to run a robot from home. You're sitting in front of the computer. The robot is working kilometers away from you, and you have connection. Think about different kind of problems you might face. Okay. The basic fundamental issue is, sorry, just I'm sorry for interruption. Just give me a second. I'll be back. Hello?
Hello.
Okay, can you hear me? Yeah, good.
Yeah,
Very
we can
good.
hear you.
Okay, very good. I'm sorry about that. I apologize. I have to check something. So, manipulator, think about that experience. You want to run a robot from home, okay? The first classic problem you have, this is very classic. This is the same issue if you want to run a robot on Moon or, control a drone from a base and to use it. The issue, the basic, very, very simple problem is what is the basic and the simplest problem you might face here? It's better to ask
Communication issues?
sorry, communication issues. Yes, you might have interruption in your communication. Let's say your communication is also good. You don't have any problem. What is the next problem?
Latency.
Latency in?
Feedback. Like when you make a move, it takes a few seconds or even half a second to respond.
There is a delay of delta t here.
Yeah, time
So
delay.
has it happened to you ever? You see, you try to move something. When it moves, something happens, and this delay between the time you get the information and the time it takes your decision will be applied can basically in control theory. So this is like a fundamental limitation. Has the capability to make your system unstable. It's like someone with a delay, with someone who is very, very slow. Think about that. Someone who is very, very slow tries to drive a car. It's very likely to cause an accident, to car crash because by the time you get the information, you make the decision, and you apply the change, something might happen in between. So this is a very, very basic classic. That's why this robot has to have a kind of autonomy to compensate this delay, to create a proper platform. So you should not need to say every detail of movement to the robot. Robot should be able to decide, and you can only make decision about larger movements, larger displacement, rather than every detail of the very popular and very actually interesting application is tele operation. So in tele manipulator are entering into medical area as well. So we have a surgeon here, someone somewhere else for a reason doesn't have access to a surgeon and needs an operation. If I have this robot placed over there, the surgery can be done remotely. But same problem as previous example I gave you, even worse here because you're working with a living human or creature, and you're trying to use the robot. Speed, accuracy is vital here. It can be lethal if you do a mistake. If your robot do a mistake, or if your robot goes unstable, if your connection gets into trouble, disruption, all these can be issues. But progresses are coming, and also in some cases we don't have any other choice. I don't know, have you read this story of this lady who was in South Pole and couldn't come back for 6 months, and she realized that she has a cancer, I guess, and had to some biopsy and send that sample, and she did surgery on herself. This is kind of nightmare when you read the story. It's really, really I don't say scary, but it's well, it gives me comfort that I'm somewhere close to other people. Okay, any question or any ideas here? Any other application for remote manipulator or telemanipulators? No? Okay. And exoskeletons are other example of robots. In this kind of robots, actually, these robots are like something you wear them. You have them on you and help you to do things which you cannot. It can be for people with moving difficulties, how to move or help them to do things which they can, or it can be also used as an extension. You can move, but you want to move faster, or you want to become stronger in movement. So these robots are in a class of exoskeleton robots. So lower limb exoskeleton may increase the strength of the healthy person to enable training of walking in paralyzed patients or subjects. Also for upper limb, we have that, people who have lost or have difficulty in moving their upper limb also might use. This is also a medical application for robots. Unfortunately, in this course, we don't go in that direction. We don't talk about specific application in biomedical. If you're interested, I'll encourage you to do your research or go through some studies on your own or do a presentation in the class. I will be more than happy to help with you and do whatever help you to do whatever you need to learn and go in this field of work. Okay. The other category, last category of robots here in this book are biologically inspired robots. What does it mean? These are robots in which we try to be loyal to nature. We try to learn from nature. Although the previous robots as well, the concept, the basic of robot is also coming from biology, from nature. Having something moves, an arm. You look at normal robots; they really look like an arm. A different arm, but very similar to a moving arm. And or think about vision, very similar to our vision. Sensors, very similar to our sensors. Although they are coming from nature and biology, but this class of robots are uh, trying to do things very similar to biology, like humanoid robots, robots which look like they stand up. They have two legs, two hands. They have head, shoulders, body, like what you see. And that are different kind of these robots. A lot of beautiful and interesting projects. I suggest to have a look at what Boston Robotics do with robots called Atlas. Very interesting. Have you seen that robot, Atlas? Has anyone seen that?
Yes,
I can hear the beep, but I don't see the text. Yes, yeah, you have seen that. Yeah. And they do very, beautiful movement. Even, well, not every human can do what they do. The most popular, probably, the industrial one is what Honda has made. Have you seen Honda's humanoid robot
no,
called Asimo? Asimo. If you search for Asimo, you see, looks like this little guy. One of this, I think this one, yeah. You can. It's too close to me. Yeah, this is Asimo, I think. Yeah, this one, Asimo. It's small. It's to help people at home. It's designed. I think it's commercial. I don't know if it's available commercially or not, but it's very popular. It has image processing, speech processing, it moves, and it has a very good grip on hand. You look at hand very similar to human hand. It can grab things, walking needs, stability. Everything is very similar to the human, and it can process. These are humanoid robots. And think about that. Designing a human robot is not an easy task. Think about dynamics of human body, because basically, naturally, this is an unstable system. You have something standing up like this and stay still like that or moving like that is difficult. Mechanically, it has a lot of calculations to make a humanoid robot move and walk smoothly, go upstairs, just jumping, running, carrying something. These are difficult. Many people argue that why should I have a robot look like a human when it's much easier to use wheels or use other shapes which are easier to do in industry. But this is another direction, and it has interest and has invest. So scientists, researchers go in that direction. What do you think? Do you think is it a good idea to have human-like robots? Is there any benefit in that? So who agrees with humanoid robots to work in industry? Please say yes if you agree. So
Yes, I agree.
yes, definitely. You want them to look like human, right? Who
Yeah, I'm
else?
more familiar with the idea. You don't see him as a
Okay.
threat, as a machine that is going to kill you with a touch.
Okay. And why Nasir? Nasir, why do you think it's better to for robots to look like human? Practically.
Yeah, it's basically when you have a robot looking like a human, especially on the assembly lines,
Mhm.
it's more comfortable to the other workers or human workers to work with the human machine.
Even
And
if
I
it's
have,
stronger, even if it's stronger, much stronger, still made of
yeah,
metal.
I spent a lot of time in assembly lines, many
Mhm.
years in Canada and US, and I have seen a lot of robots, and there are a lot of AVG vehicles and all. And there was a discussion at one point and 10 years ago that why don't we have a robot, something like a human, doing some really tough jobs which a human can't do it, like lifting the whole bumper systems and putting on the vehicle. Like currently they have like 2 to 4 people are engaged to lift the bumper system and install on the vehicle. So there we said, why don't we apply a robot to do
Mhm.
this job, a human looking robot? So yes, I agree with you. Yes, we need something robot looking like a human.
And Jason also makes a comment saying that in medical, it's much better if you have a humanoid robot to help moving patients. Yes, if you talk to nurses, this is a task. This is a difficult and very serious task. Sometimes they need to move a patient. There are equipments also, yeah, but if you have a robot, humanoid robot, which can help with that also will be helpful. I don't know, do you agree? So why do you think it's better to look like a human in that case, Jason? Is there any reason you want it to look like a human? Why not like a machine? Okay, more responsible, huh? So you can sue them, huh? You can sue them. Yeah. So yeah, all right. More friendly. Well, yes, yeah, that's a part of the actual psychology of the robots. Have you heard of these terms for killer robots, criminal robots, and more mechanically suited for the movement? Well, yes, I think yes. Oh, specifically when you think about emergency cases, there is a car crash or collapse or crisis when the things happens because although as I said, human body is very vulnerable, but it's very adaptive to different environments. You can go easily, you can swim, you can walk, you can climb, you know, different type of movements. Okay, look like robot Sophia. Yeah, Sophia. I'll talk about Sophia as well. You know, I like it. It took attention more than any other. Yeah, this is psychology behind it. So, definitely good or bad, they're coming. Anyway, I don't know. People are working different pet-like, even pet-like robots. Well, looks creepy, but is a humanoid robot. I hope to have a face covered with something more human-like. Humanoid robots are equipped with various sensors assessing their environment and sorry, movement of upper limbs and learn through human action. So interaction with human is and living and moving into human environment is much easier. So I cannot have an industrial in my home. It doesn't fit, right? But if you have a humanoid robot, it's much easier. It can come upstairs, you know, easily, can open the door, can walk through different places in the house. So since we want robots to work with humans, it's better to build them to fit in the environment which human can go or follow human wherever they want to go. It's not just humanoid. There are other inspired robots which are get inspired, robots which are inspired by different creatures, insects. I think more than anything else, insects have been interesting to researchers and scientists. Snake-like, you know, this one definitely looks like, reminds you what, this robot? This Lambert.
Scorpion.
Scorpion, yeah, exactly. Exactly looks like scorpion. You see, I don't know, is it intentionally they designed it like this, but it has legs and can move in an uneven surface easily. They don't need to pave the road for this kind of robot. They can move around, and snake robots are mostly useful in rescue missions. You know, when there are you know, collapsed, scary looking, yeah, collapsed buildings, or you know, they can go through with minimum disruption, because you know when there is a collapse area, you shouldn't move anything, because some people, it's very unstable. Some people might be you know, underneath the you know, collapsed buildings. So this snake type is very popular in rescue kind of robots, and a lot of interesting applications and research in this, military research. I don't know, have you seen this robot again by Boston Robotics? It's called Big Dog. It looks like a dog or a donkey or a horse can carry a load, and it walks. It's beautiful. If you look at it, you see the technology, the design they have implemented is fantastic. It really, really looks alive. And industrial, which will be main focus of our robot. So I leave it here. I think for today we have, sorry. Okay. Yeah. It froze. Okay, good. So any questions so far to this point?
No.
All right. So thank you very much. Today what we did, we had a brief review on the course outline, what we're gonna do this semester. the evaluation, the topics will be discussed. We briefly reviewed basic concepts in robotics. It was an opening introduction for the robotic course, and briefly review different type of robots. Beautiful discussion about what do you think and what we have, what we're gonna have. So I want to close up with this question. Like in 20 years or 10 years by now, 10, 20 years by now, what do you think will happen in robotics? What do you think will be there in 10 years, 20 years from now, which we don't have right now? Well, I would like to hear what you think.
Replacing people.
Sorry, we are going to see what? People?
They're going to replace people because a lot of places I deal with can't find people to work.
Okay, so replacing people. Yeah?
Yeah, more to do with a lack of getting people because of country to
Okay.
country in agriculture. It's a big issue.
So you're suggesting that robots are taking our job?
I'm suggesting there's more people on the planet. They can't pack food fast enough for the people.
Definitely, it's not something we make a decision. You know, money goes just wherever it finds more benefit, more profit out of investment. So you're right. You're completely right. So for sure, we see more robots around us. I have done this discussion in all other courses I'm teaching because it's very closely related to what we do. In Industry 4.0, I suggest you, for those who are not familiar, I know many of you are, Industry 4.0. We're gonna have more robots. We already do have robots. We're gonna have more robots, smarter robots, connected robots in industry, and every aspect of manufacturing, from ordering, from marketing, will be managed by systems built up of artificial intelligence in the intellectual side and robots in manufacturing side, and we as humans will sit in between them. So can you tell me right now what is the percentage of the work in the industry? What percentage of the work is done by robots and how much is done by humans? Is it 50-50? Is it 60-40? Human is doing
In agriculture, it's
how much
very
is done by
minimal.
human, how much is done by robots? In agriculture is probably
Like-
more human, right?
Yes,
Okay. How about
it's only
in
like
car
5,
manufacturing?
10%.
How about in car manufacturing? Guys in car manufacturing, what is the percentage of the work which is done by robots?
I will say something around 40-60, because most of the robots are in the body shop, but once you come on the general assembly line, um, we have very, very less robots. Maybe a couple of them I have seen in the
Okay.
plants. But in body shop, we have extensively robotic area, completely jammed with robots.
Okay, so 60 goes to robot, 42 human, right?
Yeah, paint line, body, weldings, these all areas are dominated by robot. There, you can say 95% robot and 5% human.
So everyone, does everyone agree with me that this percentage, whatever it is, in any industry, it can be, in medical, it's definitely much lower, much, much lower. In agriculture, still low. In industry, some are much higher, much, much higher. I can tell you in electronic industry, in electronic manufacturing, building ICs, over 80% is by robots, because it's not something you can do by hand. You have to you have to have machines doing it because these are nano micro scale devices to be built. But I suggest that probably in 10, 20 years, this percentage definitely will increase for robots and will decrease for human. I'm talking about the percentage. I'm not suggesting that number of human workers will be reduced. I don't know because it depends on economic growth and depends on many other different aspects. Okay, but the percentage of the robots will definitely increase. Agree? I hope you agree.
Yes.
And other suggestions is, yeah, thank you. More mechanically, so a medical and nanocellular level robotics technology will be more. So Jason suggesting that. So Jason, do you have any story for that, backing that idea, or?
I have a story.
Yeah, go ahead.
I had a robotic operation surgery on me in 2011,
Wow.
about nine years
Okay.
ago, in Toronto. So invasive surgery they call
Okay.
it, and they call it invasive surgery, and the robot was used actually to do the surgery. I was amazed. That's
Okay.
in year 2011.
Mm. And
That's
wow, good. And everything went as was expected.
it went so perfect, unbelievable. It went so perfect,
Cool.
and it happened in Toronto General Hospital in Toronto itself, which is a specialist hospital for heart and lungs and all other things. So it was
Wow.
a
So it
good
was a
surgery.
serious surgery.
It was a serious surgery, but it was invasive and unbelievable. When I told the story to my other friends, doctors in my family, I got 5 doctors. They were like unbelievable. They couldn't believe it, how the surgery has been done by robot.
Mm. Wow. So good story, life story, right? So in support of Jason's suggestion, so Jason is suggesting that there will be more nano and cellular level micro robotic technology. Yeah.
That's
So
true.
we're becoming transformers, huh? And Mike is suggesting the robotic industry will advance more. However, I don't think we will be in any different in what it does in our environment and workplace 10 years from now. And why do you think like that, Mike? So you're saying that the percentage of the robot jobs will be the same as human in 10 years, 20 years from now? You have your mic? You have your microphone? Or?
I think you're going to
Okay.
see the pandemic speed all the robots up because of people not being able to travel and go from country to country and work.
Oh, with the pandemic?
Yes.
Well, actually, that's interesting point. Yes, because we are forced to be removed from our, well, more or less on average from our job. Some people never stop going to work. Some people still not going to work. So on average, uh, as we now rely more on online things for communication, so probably we also need some remote actuators, remote doers, remote robots to do our job. So if we can, who knows, we can make a proposal to Ford to say, okay, you can let your workforce stay home and work from home with robots. Who knows? Okay,
Yeah,
match our, yeah,
Mercedes-Benz
yeah,
built
go
a
ahead.
company in Germany to build the cars 100% with robots. They have around like 100 engineers in the plant doing the programming and working with the robots, but remaining the
Yeah.
whole company from start to the end of the car manufacturing is by robots. That's a large
See?
application they have.
And I think it will be more and more. It will be more and more. Yeah.
Yeah.
And Jordan is suggesting match our movement human. Okay, sorry. And Jason, for surgery sooner than other technologies. Yeah, we got confirmation for that. One example. Also, dependent on things like network speed, like 5G. Okay, so you said you don't have. Yes, I agree. It's 5G, first, fifth generation of mobile communication. Generally talking about actually communication quality, speed, and outreach. So we have a network everywhere. We have it with good speed and we have it with high quality. So yeah, that's definitely. But you see the trend in communication. Communication wise, it's growing. It's growing fast. So I agree with the communication, but apart from communication, because you're thinking ahead of time, because with robots, you're suggesting robots are gonna be collaborating with each other, communicating with each other. Yes, and controlled by human as well. I think we're gonna see more. So, and Alex is suggesting from a programming side, I think all robots will soon be a lot simpler to set up, plug and play, like programming. Yeah, I agree with that. And preset functions, uh, cooperative robots, for example, follow chart logic. Anyone can simple application in the middle. I agree with that. That's one of the basic trends in all technologies. When a technology comes out at the beginning, it's not for everyone to use. Not everyone can use it. Even first computers were built in around World War II, WW2. Only few people all over the world knew how to work with it, to program it. Everything was in 0, 1, wire connected, not connected, very complicated. But now you see even a kid can not only work with computer or cell phone or tablet, but also they can learn to program a computer. Much, much simpler, writing much, much more complex programs because we are stacking on tools and devices in between ourselves and the system. For robot, definitely will be the case. I agree. I agree with you. That's one of the interesting. And when you compare robot programming now with 10 years, 20 years back, you see that it's much easier now. Much, much easier. I don't know. Have you heard of ROS? You know what is ROS? ROS? Anyone? ROS stands for I haven't heard. Yeah, Robot Operating System. Robotic Operating System. It is an operating system like what you have for Windows, Linux, Unix. These are operating systems. Android. These are operating systems sitting on top of your hardware, make it useful for the operator, for the user. Right? Operating system is a layer of software, lowest level, sits on your hardware and makes it useful, like Windows. A laptop and a computer without operating system is useless. You don't know what to do with it, right? ROS is an operating system built for robots. It's already in use. People use it in industry, in the military, in research. Okay, they're gonna grow. They're gonna be better, richer, more libraries, easier to program. I agree with that point. That's a very, very good and important point. Becomes much easier to use, much, much easier. And many type of machines have proprietary interfaces already, like software, graphical editor, and produce functional logic internally, and can can work cycle, etc., without having knowledge exactly. Exactly. Yeah, most of operators of, if I'm, please correct me if I'm wrong. Most of operators, people who work with robots, they don't have too much knowledge of programming. And Well, mostly they don't have knowledge of dynamic and kinematic of the robot. They don't need that. They're using the robot to learn things about robot by experience about its capability, and they're not robot designers. So with a little knowledge, with this knowledge will be reduced more and more. So without having knowledge of programming language, etc., why not robot? I 100% agree with that. That's also a coming capability for future robots. I call it plug and play. You know, in software or in computer hardware, we say plug and play. You just plug it and it starts playing. For robots, will be probably plug and play. Who knows, with speech recognition technology, with language processing, you don't even need to program. You can say, you can tell the robot what to do. You can just say, I want you to do this, and robot can process that and ask for confirmation. Do you want me to do this, that, and that? And you say yes, do that. And well, who knows? Probably but will be done. And if robot some aspect of AI, it also can figure out all possibilities and give you suggestion. Do you want me to do this or that in a much even easier way of programming? Because think about that. You have a bulky, big industrial robot made of steel, right? It it wouldn't be a big part if I have a computer case, bigger computer case, or GPU or some higher speed, more expensive computers connected to this to do AI. It doesn't, well, it won't increase the price that much, but will increase the capability a lot. And we're going to have that. So the computing portion of the robot will be increased and improved for sure. Okay. Any other suggestion? Okay. So I think we're done here. I can close down and stop recording.